Hey everybody, it's me, Mr. Lindley. We got a cup of Joe hanging out in this lovely apartment where I'm spending my time. It's gorgeous here. That's delicious. Let's get into some data action. Let's get into this data. To the internet. Hi. Now, we already have the data here. What I didn't know, because I don't know if you knew this, if you just clicked store, you just copy and paste it clean into Google Sheets. So that was a cool thing for me to realize. First graph we're going to make, was charge and force. Now, if you look at these numbers, so for this first one, I'm not going to need this. Kept it the same anyway, so delete the whole column. These two are the same. Why would these two be the same? Wasn't there that thing by that guy? Oh, Newton's eighth approximation, right? That's the one, right? That's the one. Third law, right? So these are the same. So I'm gonna delete that column as well. And now I kept this at 1. So because I kept that at 1, that makes this really easy for me. So now I got these two, which I'm gonna try to now make the graph from. So we will highlight these, we will insert, we will hit chart, and boom. Now I'm not happy with that because that's a line. Remember, we always want scatter plots. That looks pretty linear. Now I'm really unhappy with this graph. Why? That's right. We don't have a vertical axis right now. So we're going to horizontal axis. We're going to hit minimum at 0. And now I got my graph. And now I don't know why that closed so quick. Let's head back in here to customize. And I want to add a trend line on this. Poof, dash looking good. R squared is 1. What? Are you kidding me right now? Custom label, use equation. How is that even that good? That is insane. So now let's try to take that, right? Let's try to take those values that are there and let's attempt to now write a mathematical model for that graph. So we got our graph, we got our little drawing thing here, and remember for us, I'm gonna try this out. So this is y equals mx plus b. But here, this number, 1.59 e negative 3, that's really, really small. So that means we're able to say that is negligible. And can I change the color of those? Purple. Nice purple. All right. So now what is our y? It looks like this is clearly force. This would be equals. And now I got 0.311, and now the units on this are going to be the vertical units divided by the horizontal units. So this would be newtons divided by microcoulombs. Close that, and this is going to now be Q. Q is the symbol for charge. Q for charge. Those things that make sense, like P for momentum. Great. So boom. Mathematical model done. Oh, if I go, that's aggressive. For my first graph, all set, ready to go. Let's now head to the second graph. And I'm going to enlarge this now. So, why are you trying to do things? Oh, hi. So with this one, I am going to delete that second force again. Notice again they are equal because of Newton's third law, so I can get rid of those. But now I'm really looking at R, and I don't really care about the charges. You see, I picked 8 and 13. I was just trying to pick different numbers than you did. I imagine a lot of you just left it as 1 and 1. So I'm going to delete those. So now I got these, and now I will highlight this data, insert, chat, making a chat. Chatty, chatty, chat. I know that's not the song for this, but sometimes you miss it. Do I really have to add a trend line to this to understand that that's not a thing? But I do want to go to horizontal axis, minimum of 0. And great. So it's pretty clear to me that this is going to have to be an inverse graph. So now if you remember graph shapes that have this look, we're going to have to actually invert the R values. So instead of having R, this will now be 1 over R, which means my units will be 1 over meters. So what I'm going to do here, remember the little trick, is I'm going to first hit equals, okay? And then I'm going to do 1 divided by, and I'm going to select that first R value I have, and then I'm going to hit enter. And what that's going to do is that's going to take my first R value and invert it. And now you notice here I have about 20 data points, so that means I want to pull this down about 20 boxes, and I'm at 25, so about 45. And see, I pulled a little too far, so we can just delete those. Great. Force data is going to stay identical, so I can just take this, we will copy it, and we will paste it. And now that I have this data, I'm going to highlight it. Right, I'm gonna hit insert, chart, and we see now we get this graph. And if you look, so again, let's go through our standard thing. Horizontal axis, gonna make sure that minimum is 0. And now I might be happy with this, I might not, but let's add a trend line and let's see. Oh, okay, I'm not happy with that anymore. Get the R squared on there. 932. Now 932 in an actual lab setting, we might be like, not that bad, but realistically this is simulated, right? So this data should be flawless, so it's not good enough. I think it's pretty clear to see though that that's a top opening shape. So now I'm gonna have to take that data, so now I'm gonna have 1 over R, but I'm gonna square that, so that's gonna end up being 1 divided by R, but that's gonna be raised to the second power, and then that's 1 divided by meters raised to the second power. Note that the square is in the denominator there. So now I can hit equals, and what I'm gonna do now is all I have to do is take that data that I just made, so boom right there, and I'm gonna square it. And the way we square that is with the caret, so the thing that's on the 6. So shift 6, and then I'll hit 2, and then I will hit enter, and that will square that data set there. And then I just have to drag this down, about 20 of these in there. Too far. And again, this should already be in my memory. Boom. So I can just paste that force data there. So now, fingers crossed, chart. Boom! That's looking beautiful, and it actually made a scatter already. Oh, and it add the axes. Oh, you're so sweet. Go give me axes. But again, let's check just in case. R squared of 1, flawless, and we'll use our equation here. Boom. So now let's bring up that Google Keep window again. And now what I have with this, let's change this up. Oh, that's a fun color. Okay. So again, we got that y equals mx plus b format. But if we look, so now it's going to be f, right? And that's going to be equal to, this will be 0.936. Units on this are going to be crazy funky because the units here, right, would just be newtons, no big deal. Divided by, these units are 1 divided by meters squared, right? And we could certainly simplify them, but I don't want to, so we're not going to. And now then this thing here would be time, so as my variable, my x, would be 1 divided by, and I'm gonna write this as a capital R to make this easier to see, 1 divided by r squared, and that intercept is negligible, so we're all good. So now this has that 1 over r squared thing, which is kind of interesting. Not to get too crazy, if we think about this, right? What were the things in this experiment that were remaining constant? What are some of the things that we didn't change? Well, in this version of the experiment, we didn't change the charge, right? The charge remained constant. But I don't think it should be that much of a leap for us to guess that this slope here has to involve my 2 charges. It has to be related to those 2 charges somehow, because that's fundamentally what's going on. Now, got it. Now the official equation, if we look this up, what's the official equation color? Oh, this is different purple. Would look like this. So it's F, and we put a little E. That E stands for electrostatic, because it's electricity, but stuff's not really moving. And now this slope here is actually K, Q1, Q2, all divided by R squared. This, as it's written, is officially known as Coulomb's law. Coulomb's law. It's probably the coolest law you've ever learned about. It's the coolest. Now, what's K? K is an electrostatic constant. If you ever need that, that is actually on the equation sheet, so on the side that no one uses, right? That's where we'll find that. And this is the equation that dictates all of electrostatic forces and how charges interact. Now, if you notice, this looks very, very similar to another equation that we know, right? This is very, very ridiculously similar in style and shape to our good friend, you know, Fg is big G m1, m2, all over r squared. They look super similar. They both have a constant, they both have two things in a numerator, and then they both have the r squared. So that means the r squared relationships are going to be the same between these two things. They're both related to something. The big difference between Coulomb's law and the universal law of gravitation is that mass comes in one flavor, right? For us, at least, it's called mass. But charges could be positive or negative. So gravity is always attractive, but meanwhile, the electrostatic force could be attractive or repulsive. And if we remember, a while ago, we had those jokes where it was like, hey, gravitationally, I'm attracted to this pen. How you doing? But electrostatics, we can actually get attraction or repulsion. We can get both of those. So yeah, Coulomb's law. Now, knowing the constants, not really crazy important, but K is a lot larger than big G. So K is 10 to the 9, and big G, if you remember, is 10 to the negative 11. So 9, negative 11, right, as exponents is crazy different. What that basically tells us is that in a battle head-to-head with these two, electrostatic forces win, which is why in a subatomic level or an atomic level, charges play a much larger role, than mass does. But then on a more of a macroscopic scale, like with us, mass plays a larger role because most things are neutral normally, so net neutral. So like something like me, right, I'm pretty close to being neutral. My charges are roughly balanced out. Great. So we got analysis, a little intro to Coulomb's law. Hope this helps with your analysis, and any other questions that you have, feel free to shoot them over. I am gonna head back to my lovely apartment that I'm currently in. It's like a studio loft. It's so very nice. I hope that you have a lovely rest of your day. Thanks for watching.